Hey guys, Peer Dependency here, and we're going to be doing a source code review of one of my all-time favorite front-end code bases, Vue.js, specifically the Reactivity package in Vue.js. If you're familiar with Vue, you know that Reactivity really is at the core of its public API. The composition API wholly relies on it. In fact, pretty much every aspect of Vue uses this package. If you are a Vue developer by trade, like I am, learn how this package works. If you can grasp how this is working under the hood, you will understand Vue.js far better, exponentially better than 99.9% of Vue devs out there. Before we get into the source code review, ES6 proxies. That's going to be a big deal in this source code review. I have another video where I explain what proxies are, how to use them, and we build a few things with proxies and see just how powerful they are. I'm going to drop that link down below, so make sure you go check that out if you're not familiar with them, because they are going to be pretty integral to the source code we're looking at today. That said, this is one of my favorite code bases. Again, it's super creative. I'm really excited about this. We're going to go ahead and grab this Git remote, and I'm going to pop open a shell real quick and cd into my temp directory. I'm going to go ahead and clone that. Something that I like to do when I read source code is I will often go through the commit history and check out an earlier version, especially if it's an open source project. The reason being, with Vue 3, for example, Vue 3 has been around for some years now. It's got a lot of contributors, a pretty big community. You can see it's a fairly popular project. I think the original Vue repo for Vue 2 has like more stars than almost anything on GitHub. And over the years, lots of contributors are going to come in and they're going to open pull requests and they're going to be merging code in to resolve things like small bug fixes, weird edge cases that need to be handled. And these sort of artifacts kind of accumulate in the code base over time and make it look really complicated. And there's a lot of things that I think for our purposes today, the endeavor of reading the source code and understanding how Vue's reactivity system works, I don't think it's going to be particularly helpful to us. What I'm going to do is check out an earlier commit. I think we should just go for the original 3.0 release. That means we've still got all of the betas and alphas and release candidates before that. What we're going to look at today is going to resemble very closely reactivity as we see it today. First thing is I'm going to cd into the core repository and we're going to find the commit for version 3. And I'm going to guess we need to prefix this with the V. There we go. Got that commit. And we're going to check it out. And I'm going to go ahead and open not this entire monorepo. And yes, as you can see, Vue is structured as a PNPM workspace monorepo. It's got a lot of different packages, but today our primary focus is again just reactivity. For the sake of brevity and not having to sift through a ton of code, we're going to go ahead and open this in the IDE. Let's go ahead and start in the index file just to take a look and see what's going on there. We see all these things that we're exporting here, and quite a few of them are very familiar. We've got the reactive function, we've got computed, we've got effect, we've got a few internal things here, we've got some types, we've also got a few utilities. Shallow ref and ref, these should be familiar to you, assuming you're familiar with Vue 3 and the composition API, which if you're not, this video might not be for you. I would recommend learning about the composition API, checking that out, and then coming back. Or if you would find it useful, we can do a video on the composition API. Just drop a comment down below. I want to look at what's going on with reactive. We've got a few types here. These are used by Vue's internals to determine the state of whether a variable or object is reactive. The raw flag, for example, raw is something you're going to see a lot throughout this code base. And basically raw is just a synonym for not reactive. We have a WeakMap for read-only map and reactive map. This is going to be critical to understanding how this whole setup works. Weak maps are collections of key value pairs whose keys must be objects, and it doesn't create strong references to its keys, meaning the object's presence as a key in WeakMap, it doesn't prevent that object from being garbage collected. Very similar to weak refs. So once an object used as a key has been collected, the values in the WeakMap are also going to be garbage collected and finalized, as long as they aren't strongly referred to elsewhere. This is going to be important because reactivity in Vue uses proxies. In Vue 2, reactivity was implemented using object getters and setters, and it was kind of a hack, in my opinion. There were all sorts of weird edge cases that it was difficult to implement the handling of those in an elegant way. But if you're familiar with the ESX proxy, the idea behind a proxy, and we'll see this in just a moment, is that you can intercept an object. So whenever the code is trying to access an object property or set an object property, you can run what are called traps. Kind of think of them as getters, setters, and they will run, and you can even return a value that's not actually there. It's quite useful. So here's our reactive function. You see we have a couple function overload signatures here. And first thing we do is we take in this target. It's an object. Okay, so this is saying if this is read-only, we're just going to return the target itself. Otherwise, we do create reactive object. And mutable handlers, mutable collection handlers, let's take a look at these real quick. These are going to create the proxy traps that run. So this is for get. The way this works is, say I have a proxy. The second argument is going to be an object. Now, if I give my user not X back from, imagine this is a function, and I give them proxy back, everything they're going to do is going to be intercepted. When a user is typing their code, and by user I mean developer, when they do something like this, this is going to trigger the set trap. There is also the get trap, which simply doing this, referencing the object property, this is going to trigger the get trap. And you can just put all sorts of logic in here and execute it every time this happens. So that can kind of hint to you how all of this stuff is working. Let's see, create instrumentation getters, utility types that are, or utility functions that are determining how to handle things based on these internal flags. We are using reflection here to maintain the integrity of the object and its prototype, which is pretty damned important with proxies. You can get into pretty nasty situations if you are messing around with an object inside of traps and you lose the reference to its this context. Reflection kind of helps you maintain that. Let's go to create reactive object and see what we do. So we get the target, which is our original object. This is literally what's happening in Vue when you pass in an object to the reactive function. So this is what's going to run. If the target's already a proxy, we just return it. The exception here is calling read-only on a reactive object. We're not going to get into read-only today. It's kind of out of scope for the reactivity package. Here's what's interesting. When you're using the composition API at runtime, we're going to create these maps. And these maps are global variables. And this is where all of the references to the reactive variables are going to be stored. And what's really interesting, WeakMaps use an object reference as a key. You can store several copies of the same object in this map, and you will be able to retrieve each one's corresponding value contingent on the actual reference of that object. That's what we're doing here. We're first checking to see if there is an existing proxy. So we pass that target in. We literally just pass the entire object in because that is the key for the proxy map, and it's going to return whatever that corresponding value is. And here is where we actually create the proxy. We're taking in a target and we're returning a reactive object. Ergo, if that object's already reactive, we're just going to go ahead and return it. No point in going through this whole rigmarole. Same thing here. If it's already in the proxy map, there's no point. We just return it. Otherwise, that's where we really start the proxy creation. We create the proxy. We're setting it in the proxy map. Relatively straightforward. The other half of how this works is effects. All data that is reactive in Vue.js runs hand in hand with effects. And if you're not familiar with what effects are, think of watch. When you use watch in Vue.js, you pass in a reactive data type, and anytime that data type changes, the second argument you pass to watch, which is a callback function, gets invoked. How does that happen? How do they know that that object changed? That's where the reactivity comes in. That's where the proxy comes in. They are running these proxy traps, and every single time you either get or set, it's going to trigger these traps. You see, we've got collection handlers or base handlers. This is really based on whether it's an object or an array. kind of a big deal with proxies. Handling arrays with proxies is just a huge pain in the ass because the way that arrays are implemented in the actual JavaScript engine. If we're talking V8, for example, the C++ implementation of arrays, length is an object. It's a getter, setter object. The actual indices are objects. Everything is an object under the hood with arrays. And that means every time you set the length explicitly, it triggers the proxy setters, and it can cause all sorts of weird edge cases and kind of crap that it's just a pain. And that's why you'll see that the Vue devs have these instrumentations specifically for arrays. So this is the set function that is run by the proxy. If you'll recall, for our example proxy, we said new proxy. We've got the target. The target is literally the target object. We have the key, or this probably would be more aptly named property. This is a property on which we are setting the value, which is the third argument. And then finally, we have the receiver, which is either the proxy itself or an object that inherits from the proxy. And we don't need to get too into the weeds about what this value could be. We're not really doing too much with it other than reflection. What happens if I implement this in my code and I say x.x equals 21? This is going to trigger this trap, and this is going to run before this value is actually updated and reflected at runtime. We're going to get the target, which is going to be this OG object. We're going to get the property, which is going to be X. We're going to get the value, which now is going to be 21, and then the receiver, which will be this actual proxy itself. This affords us some pretty interesting opportunities. When they create the setter, they can pass in a shallow flag, whether or not they want to deal with shallow reactivity or deep reactivity. What this means is a reactive object could be recursively a proxy. If we go back to this example here, we could make this X property a proxy as well. That's the tricky thing about proxies. They don't have this sort of depth just by default. X.X is not going to be reactive, or rather, it's not going to be a proxy. It's not going to trigger traps after a certain point. If I say X.X equals another object, we're going to run into problems. Typically, the remedy for this is to use a sort of recursive approach where you return a new proxy. And I believe we'll probably see that somewhere in here, where at some point we just return a new proxy for the actual object field that's being accessed. That way you get X.X and maybe X.X points to another object. That's going to be a proxy and so on. That's going to probably be in the getter and not the setter. That said, if not shallow, value is probably going to be reactive. So we run to raw, we check arrays is ref, and then we set the value. We return the Boolean flag that indicates whether the value is actually set. That's just implementing or satisfying the proxy API. Now we're going to use reflection to set, do some other logic here that I don't think is particularly important, except this is what we want. Trigger is the core of how this is working. Trigger is going to run an effect. And where do these effects come from? Well, when you do a watch effect, the callback function that you pass in gets correlated with that object. For example, if we have a watch and we have some reactive object here, which is what we're watching, and this reactive object has been passed through this whole rigmarole and it's turned into a proxy, and then we have our callback function. This runs anytime the reactive object is mutated. We receive as parameters the next value, the previous value. This effect is what is stored in the proxy map, and this is the value corresponding to the key reactive object. It's something like this. Technically, we have a WeakMap. It would literally be this. Const callback and callback. This is what the proxy map looks like under the hood. So anytime you mutate a reactive object in Vue.js, we run this set trap and we hit these lines and we run this trigger function, which we'll look at in a moment. And trigger says, hey, go get me that proxy map, use this object to look up the key in that map and grab the value, which is going to be a reactive effect, or as we're going to see, a set of reactive effects. And I want you to run them, and I want to pass the actual object, the key and the value, these are the things that we're mutating on that object. We're also going to pass in a flag that tells us what type of operation is happening here. Because this is a subtlety that you kind of have to pay attention to with proxies. You need to be careful whether you are adding a new field to that object, a new property that didn't exist before, or if you're mutating an existing property, which would be the set flag. And we'll look at trigger and we'll see how these work. So this is the trigger function. And the trigger function is going to get the depth map. This is a nomenclature that is specific to Vue.js. They call the effects dependencies. Dep is just any effect set that is going to run for that corresponding reactive object. For example, here with trigger, we triggered the proxy trap for set because we mutated our reactive object. And under the hood, Vue figured out that we need to run all the effects, all the watchers and whatever computed properties that rely on the reactive object. And we're going to go and grab those values in the proxy map. We're going to get target map, and we're going to use the object. So remember, in the WeakMap, you can use objects as keys. You can use object references to store values that correspond to them, and we're going to grab those. Now, if there are no dependencies, then it's not been tracked. That means this probably is a reactive object, but there's no watchers, there's no computed properties that depend on it. Why bother with all these computations? Let's just return early. Here we're going to declare a new set called effects. And this set is going to be an in-memory set in this function closure that we're going to add all the effects that need to run here, and we're going to schedule those to be invoked. We declare a function named add, and if there's effects to add, we'll run this later. And we'll grab these effects, and for each effect, if it's not active, and we'll go into what active means in a moment, we're going to go ahead and add it to that set. And if the key is not undefined, we're going to use that add function, and we're going to grab the dependency corresponding to the key, and we're going to add it to this effect set. I'm going to break this down because I think this can get a little convoluted. What's going on here is in that proxy map, the value is another map of dependencies, and each dependency is based on another key, and this key is the actual property being set. Let me show you in code what this is going to look like. We have our target, we have our key, we have our value, and we have our receiver. Say my object is x and 1. If I go ahead and say this, whatever, what happens if we have a watcher and we're using the getter syntax, the function syntax, and we're watching this specific property on the C object? We're not just watching the entire object with maybe a deep flag. We're not doing this. We're just watching C's X property specifically. That's what we're looking at here when we grab the key. The key here would be X. We only want to trigger X for the X property of the proxy C, or reactive object C. That's what we're doing here. We're getting from the depth map. This is the depth map that corresponds to this reactive object generally. This reactive object is the key for this entire map. And then we're going in that map, the value, which is also a map, and we're using the X field to grab that effect, which is literally the callback that you pass to this watcher here. So we add that, and remember, the add function literally just goes through the effects and it adds them to our effects set here. And we're going to run those in a moment. It's part of what the trigger function does. So I'd imagine you're getting an idea of Evan Yu's code style here. He has a lot of these function expressions declared inside of the function closure where he'll declare these and then they'll be run afterward. This is going to be the run function that is going to be scheduled. It's going to take the effect. We have a dev flag here. This is only going to run when we're in dev mode, so we don't need to worry about that. This is never going to happen when you are using Vue.js. But here we have scheduler, and we're going to schedule this effect to run if we set the scheduler option. We might get into that in a little bit, but I think it may just add some complexity, we're going to go to this line here, and this is where we actually run. We saw that we declared the run function here. We are going to iterate over this set of effects, and for each member of this set, each watch function or whatever, it could be computed property as well, which we'll get into. We're going to pass in that run function as a callback, and it's going to invoke. Each effect is going to go through this whole process. That is the trigger function. Just to recap that, we create a reactive object, decide to mutate a property on that object, and it triggers this trigger function, aptly named, which runs all of the effects that have been correlated with that specific property or object. Now, how do effects get added to this map? This is a good opportunity to talk about the get traps. Remember, we have the set trap that we just looked over, but corresponding to that, we have the get trap. And like I explained earlier, if you set, this is going to trigger the set trap, and that's where we had the view setter. Similarly, say I have a function and I'm doing an if condition, and I say if reactive object.x equals 1, this is going to trigger the get trap because this is a getter operation on this object, going to trigger this trap. So let's go ahead and look at what that is. So again, view reactivity uses these create functions to create the actual trap function. So this is just a function that returns the actual function. The reason is they wanted to have these closures here so they could pass in these flags when they're creating them and determine how the runtime logic for these getters and setters are going to run contingent on whatever flags for whatever situation is appropriate. That said, we do some array checking. As aforementioned, arrays, symbols, maps, sets, they all have kind of unique handling here. But here's what's interesting. So if it's not read-only, we're going to track. Now, what are we actually tracking here? Because we know the track function does something, and when we get this object, it triggers the trap. So remember, the target could be just the entire object, or it could be, an object's property. So let's suppose in this case it's reactive object.x. So if we go to the getter, target's going to be that reactive object.x, not just the reactive object. That's what we're going to be passing into track. We're going to pass in the get flag to tell track that this was a get trap that was triggered, and we're going to pass in the key, which in the case of that example is going to be that reactive.x property. So when we track it, let's see what we do. So yep, here we've got the target, we've got the type, which is a track operation type, and a key, which is unknown because it really could be just about anything that you can have on an object. In TypeScript, that would be the property key type. Should track and active effect, we're going to look at what these mean in a moment. But the first thing we're going to look at here is very similar pattern. We declare a depths map, and that's going to be the map value from the target map or the proxy map, that global map where we're keeping track of all of our reactive objects and their corresponding effects. And if the depths map doesn't exist, we need to create one. This is going to run always on the first time a reactive object or reactive object property is being tracked, because there won't be any dependencies yet because it hasn't been tracked before. We're going to say, let's create a new depths map, and let's use that object or object property, whatever exists there, as the key, and we're going to set that in the target map. So now we do have this. And next, we're going to go ahead and get the dependency for that specific key that's being tracked. In this case, for our example, that's going to be reactiveObject.x. We're going to get the dependency that correlates there. And remember, the dependency that's stored in this map, the value is a set. It's a set of functions. Those are our effects, watchers, computed properties, whatever. Again, just like up here, if the dependency doesn't exist, well, we just tracked it and we tried to retrieve it, so we know it should be tracked. So we're going to go ahead and create it. And then we get down to this line where we are dealing with the active effect. I'm not going to get too deep into this, but what you do need to know about the active effect is this is a dep that is currently running. At the moment that this function is invoked, if one of these deps is running at runtime, that's what the active effect global variable is going to be pointing at. And if you're wondering how we could be in this function while this function is running, because of closures, basically. That's how track works, and that's how we start adding these dependencies. So again, just quick review to kind of catch up and understand exactly what's going on here. I'm going to do it over here. We've got our watch function. We've passed in reactive object, and we've got our callback function. So this is what happens. I'm calling watch. This goes through the track function. This gets added to the proxy map as a key. And then we create our map of effects with sets in them. Track gets triggered whenever we reference one of these, and these effects get added. WatchEffect is probably a more clean example of how this works. WatchEffect's implementation is a little bit more straightforward. It's going to run this effect immediately, and then anytime the dependency gets triggered. One thing that I really struggled with was understanding how things like watchEffect, how does this actually work? How do we know that this is the active effect and it's running, and that we should track this object and we need to trigger it when it changes? And what's pretty interesting is we saw back here that there was this thing called the effect stack. And what's going to happen is anytime you run an effect, it's going to get pushed onto this stack, and we're going to keep track of it. And we do that with this effect function. And so here we are with create reactive effect. And here's a code pattern that I find very interesting that Evan You uses quite a bit throughout the Vue.js source code. Effect is a function, but it's also an object, because as you know in JavaScript, functions are objects. And like an object, it has properties on it. So that means we could invoke effect, or we could access properties on it. It's simple maybe, and maybe I just get excited about stuff like this, but I think it's really creative to store metadata on a function. It's kind of elegant. That's what I love about looking at source code. Basically, this is just a simple stack, and when the effect runs, we push the effect onto the stack, and then when it's done, we pop it off. So here we have a try finally. This means that we're going to try to do this, and then at the end, we're going to pop it off the stack. This is basically our cleanup here, and then we're going to set the active effect to the very last item in the effect stack. Let's go back to where we were, which was the effect function. So we left off looking at this line. We saw create reactive effect, we pass in some options, we pass in the actual effect function, and we get back this effect. And if we didn't pass the lazy flag, we might get into that. We go ahead and invoke the effect immediately, otherwise we return it. But for now, we're going to focus on line 63 here, where we actually invoked the effect. Just remember this, keep this top of mind. This is the function that's going to add the currently running effect. And by effect, I mean it could be a watch effect or a watch. It could be a computed getter, although those work slightly differently, but kind of the same idea. But that callback, when that's running, it's going to be added to the effect stack, and it's going to be set as the active effect when it's actually being invoked. So let's go back to trigger or track and see what happens with the active effect. If there is no active effect, we return, because there's no reason to track something if there's no active effect. The only way we know what function to correlate with the reactive property is if it's running, and that's how watchEffect works. This is going to be the active effect. We're going to track this object, and because active effect is running, we know to add it. Now, if the dependency that we got out of the depths map, this set, doesn't have the active effect, we go ahead and add it. And then we track the depths on the active effect, which I don't need to really get into because I think that just gets kind of complicated. So that's how this whole thing works. If you think about it, it's kind of brilliant. And my understanding was Evan based this off of a lot of the Meteor code. If you know much about Evan You, the creator of Vue.js, he worked on the Meteor team for some time before he started the Vue project. And you can really see a lot of the influence from Meteor. I'm not familiar with Meteor personally in that I've not used it, but I have looked at the source code. In fact, I looked because of the Vue.js package. In the README, Evan mentions Meteor. He also talks about the observer util. I think this is Angular stuff, I'm not sure. And then Salesforce observable membrane. These are all just kind of classic old school reactivity packages that were inspirational to this package. I think one more thing before we wrap this up, we'll look at computed and maybe take a quick look at ref. Computed is fairly similar to what we just looked at. It's kind of a wrapper over that business logic. The actual implementation of a computed property is this class. We have our constructor. We have the computed getter. You'll notice in the composition API, when you create a computed property, you have to pass a getter function. You can't just pass something directly into it. And typically this has to be a ref. And what we just went through explains why this must be a ref. So computed, as you know, it kind of caches the value and then it automatically updates at runtime anytime the thing that it depends on changes. Now, in order for computed to know that, this must be reactive. Same thing, like if I did a watch effect and I just passed OG object. This is not reactive at all. It's not a proxy. It's not a reactive object. It hasn't been passed through the View Reactivity API. This effect is never going to run because this is not reactive. And this is why I prefaced the video saying that reactivity is one of the most important things to understand if you want to be good at Vue.js. Everything in Vue hinges on this stuff. And this is a good example of it. Similarly, a computed property, this is not doing anything for you. We need this to be a proxy. We need to have these traps in order to trigger effects and to track dependencies. Otherwise, we get nothing. We just have this plain object. And as we saw at the beginning of the source code review, when you pass these into the track or trigger, we just return if it's a plain object. So we'll go back to computed real quick. So that's our computed getter. It's a function that returns the value. And what do you know? Computed is literally just the same thing we've already seen. It's that effect function, and we pass the getter, and we're essentially watching it. So we have this effect. This is the actual value. So this getter would return a ref or maybe a property of a reactive object. And then we pass that lazy flag. So if you remember before, when we were looking in the effect function, this options object, if we have lazy, we don't run the effect immediately. And what we actually wait for is this scheduler here. The dirty flag indicates whether the value that the computed property depends on, this getter, it looks to see whether this is actually changed. We can see this logic down here. We have a getter, we get the value. So this is when you do the computed property, whatever dot value. If it's dirty, we set the value to the result of the effect. And remember, in effect, we actually returned the resolved value of the effect function. That's what's going on with a computed property. We are updating the value anytime the code references it if the dependency, the getter, has changed. That's how computed properties know to update and reflect the changes. And here we're tracking the computed property itself, and we're running a getter on this value property here. And then we have set. This is a little bit less common with computed properties, but if you've been using Vue.js for a while, you know that you can have a mutable computed property. You could pass a getter and a setter into the computed constructor, and that's what we're doing here. So that's computed, and I think we have some time to just take a look at ref real quick. This is our ref function. We've got a few overloads because ref can pretty much accept any value. Let's go ahead and look at the create ref implementation. And it's another class. We have a private field called value, this is our private member, and this is where we're going to store the real value. We've got a few flags. We've got our constructor, the raw value, and if it's shallow, we do the raw value. Otherwise, let's see what convert does. What do you know? Now we're starting to see how all of Vue's composition API really congregates about these reactive functions under the hood with track and trigger. If it's an object, we're making it a reactive object, and otherwise we're just returning the value. And I find that so interesting to see because, again, ref, just like computed and just like watch and watchEffect, they're all really kind of interacting with the same core. With our ref implementation, here is our standard fare track and trigger logic. If we get the value, we track it, and then we return the internal value. And if we set the value, we check and see if the value has actually changed. And if it has, we run trigger. This is a performance optimization. If the ref hasn't changed, there's really no reason to go through all of this again. So we go back here, and that's what we're running here. As we do toRaw, we extract the value from the proxy, and we check and we see, has the new value changed contingent on the raw value that we cached here. And if it did, we go ahead and update everything, and we run trigger. And that's it, folks. That is the Reactivity package in Vue 3. I hope that you enjoyed this video. If you got something out of this, please like, comment, subscribe, and we'll see you guys next time.